welcome to podcast.init, the podcast about Python and the people who make it great. We are recording today on May 28th, 2015. Your hosts, as usual, are Tobias Macy and Chris Patty. Tonight we're interviewing Mark Baggett. As usual, you can follow us on iTunes, Stitcher, or TuneIn Radio, and please give us feedback. You can leave us a review on iTunes or Stitcher. You can contact us on Twitter. We're at podcastdunderinit. You can email us at hosts@podcastinit.com or leave us a comment on our show notes on our website at podcastinit.com. And if you'd like, you can give us a donation. There are links on our site. Mark, could you please introduce yourself?
Sure. First, Tobias, Chris, thanks for having me on the show. Appreciate it. I'm Mark Baggett. I am an information security professional. I started out as a software developer straight out of college and developing in languages like C and Pascal and Clipper and lots of other languages that have long since been forgotten. After developing for several years, I went into networking, systems administration, and some of the other areas in IT when I finally came around to information security. So I do penetration testing for companies where they need an audit, they need an assessment. We'll come in and we'll bypass their controls, gain access to the data that they're concerned about, and show them really what the risk is if an attacker gets a foothold on their network. And I love to use Python in that process. So
very cool. So Mark, how were you first introduced to Python?
Well, like I said, I was a coder for many years, so I knew programming. Then when I got into systems administration and networking and things like that, I probably had five to 7 years of my career when I didn't really do much coding, but there was always a better way. There was always some way that I could take the menial tasks that I had to do every single day and automate them. But languages like C are not quick and easy fixes, and you have to have a process that really justifies the writing of that code before you're going to jump in and do things like that in C. But Pascal and Clipper, they really weren't around anymore, so a lot of my coding skills had atrophied in places where I could really use them as systems administration. And then I remember I was reading some exploit code that an attacker had released on the internet that was launching some attacks against an FTP server, and it was written in this language called Python, which I thought was named after snakes initially. Then, come to find out many years later that it's much cooler than being named after snakes. And just looking at the code, it was very easy to read. It was just a fun language. And so I had decided I'd been looking for a way to get back into and redevelop my coding skills. And so Python, reading that exploit and seeing how easy it was to read through that seemed like a great place to go. So started coding in Python from there, automating simple systems administration tasks and things like that. And I've just really used it since then for just about anything I need.
So what are some of the tasks in your current job that you use Python for?
So as an offensive security professional, where I'm trying to gain access to systems, Python is really nice as a very simple command and control backdoor that you put onto target systems. One of the things that makes Python a nice command and control backdoor is, well, it's a trusted platform on Windows systems. So you've got lots of opportunities to develop code, but if you take a Python executable or a Python script and then you turn it into an executable using something like PyInstaller, there's lots of legitimate companies out there that use PyInstaller to create software products that they sell to people for many years, until recently that Dropbox tray icon that you had there that would synchronize your desktop to Dropbox was written in Python. And so for an antivirus company to start deleting your Python-based backdoors, they couldn't just delete all of the Python interpreter Python code that was out there, because there's lots of legitimate programs. So antivirus companies would have to actually pull apart your PyInstaller executables, find the code that you have, and interpret that Python bytecode in order to figure out whether or not your virus was malicious code or if it was just the Dropbox synchronization tool. So it's a hard problem for antivirus companies to fix, and creating backdoors in Python was a great way to do that. It's also a great way to interface with web pages. So if I've got a web page I need to assess the security of, then using the request module or even the built-in build opener and URL lib modules to make requests to web pages, to manipulate the cookies for session hijacking, or to launch password guessing, to read a web page and then get a CAPTCHA. Not one of those CAPTCHAs that human beings themselves can't even solve, but there's a lot of CAPTCHAs that you have on web pages that people develop that are like, what is 1 + 1? Are you a human? CAPTCHAs like that are really intended to keep people from posting Viagra ads all over your blogs and everything else are not really there to keep out targeted attacks. It's more so just to keep the nuisance scanners away. You'll come across those as you're doing your testing, and you can easily solve. Python is really good at adding together two numbers or saying, yes, I am a human, to questions like that. So it makes solving those CAPTCHAs and being able to assess websites like that very easy, whereas your off-the-shelf password guessers and things like that you might download off the web can't handle those types of situations.
That's really interesting. So has there been any instances in the wild of well-known malware that use Python for a CNC backdoor that they actually install onto target Windows systems?
I am glad to say that I have not come across a Python backdoor in any of the incidents that I have handled. As someone who teaches professional penetration testers how to do these things and teaches them how to develop backdoors in Python, I'm happy to say that I have never seen it used by anyone with malicious intent yet. I'm sure that it could happen. Now that said, the thing that makes Python great, which is it's an interpreted language, so really you're not putting a malicious executable on a system, you're putting an interpreter on a system with a malicious script. That concept has been used by malware. I think the most famous case I can think of is the Flame virus that it was a huge piece of malware, 5 megabytes in size, and had nation state capabilities, and it had some incredibly advanced attacks in there against encryption and the way that we sign our certificates, as well as the ability to create its own Microsoft updates services and distribute command and control and updates to the malware through a fake Microsoft Windows update service that was installed on the victim's machines. It was a really incredible piece of malware, and that was written in Lua, and a Lua interpreter along with the Lua scripts were distributed to targets. So while I haven't seen Python used, I have seen other interpreted languages used, and I have no doubt that Python is used in malicious attacks. Particularly, you look at some of the frameworks out there, like the the Veil framework. The Veil framework is a Python framework that will take payloads out of penetration testing executables and allow you to distribute those to systems. Now, the Metasploit framework is, I like to think, mostly used by the good guys, the professional penetration testers who are there to make your network better. But the Metasploit framework is so useful to attackers regardless of intent. I'm sure that some bad guys use that as well. And the Veil framework makes it very easy to take any of those payloads that you have inside of the Metasploit framework and turn them into executables that you can run on any Windows system.
Wow. So going back to your point about antivirus practitioners having to pick apart Python code rather than just delete it wholesale from a system, I would think that obfuscating your Python code as an attacker would be a good way to try and sidestep some of their attempts at interpreting the intent of that code as well.
Yeah, either import sockets as not sockets, or making just a simple class that wraps the classes that they might be detecting. You could easily get around someone who was actually going to look at your Python bytecode and determine what you were trying to do. But that said, I haven't had to do that. I mean, it's just not a problem today. You can write your backdoors in Python, and antivirus software doesn't care about it. The only place that I see it really detecting Python backdoors today is if you have some of the products that do reputation-based filtering, things like Symantec, where they have huge databases of hashes, and they'll tell you that this particular executable hasn't been run on any other targets. This is a unique hash that we've only seen it here. Something like explorer.exe, which is running on millions of hosts, it recognizes that file and says this is explorer.exe, and it doesn't raise any flags. But when it sees a unique executable that it's never seen before, or it's not in its massive database of hashes, those I've seen flag Python executables that were created with PyInstaller. But one way you can get around that is when you use PyInstaller to create, say, an executable. You don't have it create a single exe, you have it create a directory, and in that directory you end up with the Python interpreter, all the DLLs, and your bytecode. So now on the target system, you're no longer running a custom PyInstaller executable that has a unique hash. You're running Python, which is running on thousands of computers and recognized by everyone. So that the reputation filters are perfectly happy with running Python there.
That's very interesting. What is it about Python that makes it useful for penetration testing and other information security tasks?
Oh, I mean, import this, man. I mean, what is it that makes Python awesome when developing just about anything? And it's that other people have written the hard part, and you just got to glue together all the pieces that are in the modules. There's so many useful modules out there that do these incredibly complex tasks in just a few lines of code because somebody else did all the heavy lifting for you. One of my favorite modules from a penetration testing standpoint is called Baggett, and it's by Core Security. And they have completely written all of the server message block APIs that are necessary to communicate with Microsoft servers across the network. Whether you want to authenticate to servers and do something like execute code on them using similar functionality to Microsoft's PSExec to execute code on a remote host, or do WMI queries to a remote Windows system. They've got these incredibly well written and very useful libraries written that do all of the heavy lifting. So to execute code on a remote system, I import their library, I create a PSExec object, I give it an IP address and tell it what I want to run, and it logs in, creates a service, it runs my commands on remote hosts, and captures all the output and stores it in a variable for me. So, I mean, the usefulness of Python for security professionals is I'm sure the same usefulness that every other developer that loves Python out there experiences, which is there's all of these great third-party modules that are out there that make your life so much easier.
And exposed at a very high level of abstraction, right? So as you mentioned, sort of being able to pick them up and use them, bend them to your will is relatively straightforward and takes not a lot of time and effort. Correct.
Yeah. From a security standpoint, I'll mention some of the modules that I use frequently. I use, as I mentioned, Baggett by Core Labs. Of course, Beautiful Soup and Request for talking to the web is very useful. I'll use Scapy a lot or Dpacket for just reading network packets and parsing them out and trying to find useful data in them. Something recall or volatility for parsing through memory. And then as a defender, using something like the counter module, something as simple as the counter module, or the counter dictionary, from the collections module, and Panda, iNotebook, Matplotlib to give you statistics on the kinds of people that are communicating with you and trying to find outliers. And I only saw traffic from this one IP address once an hour, for the last 24 hours, things like that, finding all those outliers. Just the regular statistical model type modules that you would see normal data analysis people using are very useful in Python for finding people that are attacking you.
That's somewhere that I'm sure when a lot of people think about data analysis or big data, that's not necessarily somewhere that they jump to immediately is doing defensive security, because they're used to thinking about it in terms of advertising or marketing or maybe even scientific purposes. But there's definitely a lot of traffic that gets generated by all the systems that we use every day, and by knowing how to look at it and what to look for, you can definitely find a lot of valuable information that'll give you information about precursor attacks or about information gathering attacks that people are launching against your system, so that you can defend against that before it actually ends up being a full-blown invasion of your network.
Oh, for sure. I mean, your intrusion detection systems that you run on your network, they do a good job at what they're intended to do, but they can only do so much. And most people have megabytes, if not gigabytes or terabytes of logs distributed across their systems. And they look at those logs perhaps once a month. Maybe they're looking at them once a week. But if they do look at them, they're looking at them perhaps in just the context of that local system and not as an entire network. But when you start looking at the logs and the systems and things you have running across your entire network, and you start putting them in context or comparing them to each other, then you can find a lot of useful information. So just take Panda, iNotebook, Matplotlib. We're just going to build some databases that are going to collect up a list of all the processes that are running on every host on a given subnet. And then you go through those processes and you see that, okay, Explorer.exe is running on all 255 or 254 hosts that I have in this given subnet. Very good, right? And then, antivirus software, that's running on 249 of them. Well, you might want to go look and see what those other ones are. But then you've got this executable called Mark's Python backdoor.exe that's running on 2 of your hosts. Maybe you should probably go check that out and find out why is it that only 2 of your hosts on your network are running this one executable. Usually corporate networks, they tend to look the same. There's always outliers, but it's when you start looking at the outliers and finding the thing that's unusual, the thing that makes a host unique, that you really begin to look under the rocks and find evil sitting there.
It's really interesting. I was a Windows enterprise developer for just a couple of years. I've been mostly a Unix guy. But I will say, listening to you talk about some of these facilities and modules that you use, one thing that I was very impressed by in my time doing Windows dev was how rich the introspection facilities are for being able to, like you mentioned, remote WMI queries, things like that. You really can sort of treat your Windows box like a database and kind of mine it in all kinds of interesting ways that the Unix universe is just only kind of now catching up to speed with. So that must make your job an awful lot easier as a security guy.
It depends upon which side I'm on. If as an attacker, could make your life really difficult if you were trying to hide, which as a professional penetration tester, I'm never trying to hide on a network. So, but yeah, I mean, to your point, if you look at Windows event tracing, just look at if you look in your Windows event logs, you've got your security logs, your application logs, your system logs, which everybody's aware of. But if you drop to that command line or your PowerShell prompt now, and you type in logman space query space providers, you'll come back with a list of over 900 on Windows 8 machine, 900 different event log providers. And these are systems that just generate Windows events, and almost all of them are turned off by default and not generating any logs. But there are so many interesting things that you can begin to capture and learn about your system if you just turn some of those on. Most of them are off because they're noisy and they generate so many logs that it's not something you would run all the time. But when I'm dealing with an incident and trying to find attackers and anomalies on systems, turning those on, you can learn a great deal of things. There's event trace providers that will record every packet that goes in and out of your network. So from an attacking standpoint, if I want to implement a packet sniffer on your machine, I can do that through your event logs with Windows Event Tracing. Or there's the Win iNet provider, which you can turn that on, and you can turn every browser into a keylogger, basically, where as passwords are being typed or transmitted, it will record usernames, passwords, cookies, and other information that's transmitted over SSL packets in clear text on the hard drive and inside of event logs. So yeah, Windows event logs and the information that's recorded there is amazingly comprehensive, and it's incredibly useful to us as both offensive and defensive security personnel. But it's a lot of data. Fortunately, Python is really good at pulling together lots of data and analyzing that data and finding useful bits of information out of it.
Definitely. So this kind of dovetails with that. We've noticed that a lot of the literature around information security and penetration testing focuses largely on Windows. Can you enlighten us as to why that is?
Well, I think it's because that's where most of our attacks are targeted. So organizations still have Linux systems in their environments. Those Linux systems are often in the form of databases or websites or a lot of appliances that people run. But your primary attack surface in organizations is still the Windows systems that users are sitting behind. So as a penetration tester, I do want to ultimately gain access to other platforms besides Windows, but it's all about where the data is. And generally speaking, you're going to come into an organization either through their external web interfaces, where you're going to be attacking SQL attacks and cross command injection, things like that, where you might be using the requests module and Beautiful Soup and things like that. Or you're going to exploit an endpoint, such as a Windows-based system there, and get a user there to click on a link and get your foothold into their organization. So I think that's why you see a lot of Python tools being written to go after Windows, because Windows is the primary target. Once you gain access to that target, you're going to look for other resources, but pretty much the attackers want to gain access to those Windows systems.
That's really interesting. I guess I had never thought of it in those terms. I guess I thought maybe it was something along the lines of, this is the majority of what your clients who are actually paying you to do penetration testing run. But I can see that it's not that at all. Like you said, that's where the attack surface is. Is it also true that Unix presents a less target-rich attack surface than Windows does? Or is that a misconception that I have as a mostly Linux guy?
Well, it depends upon what you mean by the question. So there are fewer Linux systems in the typical organization, right? I mean, in a company with 10,000 employees, I might come across 30 to 40 Linux systems that are in that environment, pure Linux systems. There's probably going to be another 30 to 50 appliances in there that are running Linux. But for the most part, those Linux systems are going to have very few ports open. They're going to have port 80 and maybe port 22 if I'm lucky. And there's not going to be a user sitting behind there just waiting to click on the executable that I send them. Whereas on the Windows platform, there is. And I think that the Linux operating system, there are fewer services that are just sitting there waiting for you to connect to them. I think some of that is just based upon the fact there's not a lot of users that are sitting behind the keyboards on those Unix systems. So you don't have to have services open for some software inventory system to come and connect to the hard drive of all these machines and inventory the software and things like that. So, I mean, there's just so much you can do over the Microsoft ports and Microsoft protocols, from administering the system to copying files to, I mean, you do everything over the SMB protocol. But as soon as you open that one protocol up, you've exposed yourself to remote code execution, and it's very similar to SSH in that way, I suppose. We like to put better controls around our SSH systems on our Linux systems, I think.
So it sounds like it's a combination of both the system itself being a little bit of an easier target, but also somewhat to a larger extent the fact that a lot of the targeted attacks into an organization are through phishing, spear phishing or general phishing attacks against the actual users behind the terminals, and trying to trick them into doing something foolish that will actually give you a foothold into the organization. Is that correct?
Yeah, I think that's absolutely correct. Although I'd say, as I'm a Unix guy, right? Given the chance of writing my Python code on Unix or on a Windows system, I'm going to write it on Unix, make it work, or Linux, and then I'm going to move it to that Windows target just long enough to make sure that my code works there, and then do it. So I'm a Linux guy, but I'll say that if you look at the number of vulnerabilities that were discovered, released, or exploits released for, and patches released for last year, Microsoft has done an incredible job, and they continue to get better and better from an information security standpoint, as far as having a secure software development lifecycle and things like that, and doing code reviews and things like that, so that they're doing a really good job with the operating system itself. Also, the fact that they can control the compiler, that Visual Studio, the compiler, is building in more and more security controls. In Linux, the power of Linux is the freedom that we have, and not being locked down with one software provider, and being able to do just about anything we want to. But that same freedom means that we're using a wider array of compilers and software development platforms, and not standardized patch management processes, and it does lead to more vulnerabilities in our Linux platforms than you see on the Windows platforms last year. That said, you're still not more likely to pop a Windows box than a Linux box any day.
And this all brings up another interesting point of, there's been a lot of discussion in Python and in other dynamic languages about the difficulty of being able to get up and running and actually perform development on Windows systems. So the fact that you're targeting a lot of your code to run on those platforms and developing it on Linux, as you said, it's just an interesting aspect of this particular industry, where a lot of the other places that you see and hear about Python being run is generally on Linux and Unix systems.
Yeah, I mean, it's there by default on many Linux systems. It's not there on Windows. We have to download it, install it, and idle is okay, and it does a pretty good job. But I can't take those .py programs and just move them to any Windows program and expect them to run. I have to turn it into an executable before I'm going to move it around from system to system. Whereas I got my .py programs, I can move that to just about any of my Linux targets or hosts, things that I'm using on a network, and it's going to work there.
And does that pose any issues in terms of trying to keep your dependencies to a minimum, as far as being able to package that all up?
It does. So it is very nice to be able to import anti-gravity and import request module. The request module is something that's, that should be built in, right? I guess there's a lot of it's just so useful. But URLlib2, managing cookies with URLlib2 is not nearly as easy as it is with the request module. But I will force myself to use urlib2 and build opener to build my scripts with only built-in modules if it's a script that I think I might be running on a system other than my own. In other words, if I think I might gain access to a Linux target inside of an environment, I am certainly not going to install a Python module on a customer's machine and alter the configurations that are there. Even though pip can uninstall, I'm still not going to make those changes to a target system. I want to make sure that the things that I move to that target environment are going to run in that target environment. So I'll force myself to use just built-in modules. But there's very few scripts that I put into that category. Most of the things I can run directly from my machine against target systems.
And I would also think that by virtue of eliminating the need to download those dependencies, it would also decrease the likelihood of being discovered in the process of placing that code on the target machine.
Yeah, I think that's true as well. Although, honestly, in almost all of my penetration tests, I can't even think of an exception. Trying not to get caught is usually not in scope. I mean, I will usually try to get caught when you get in there. You gain access to a system, and then you start to do things just to measure what the target organization's noise threshold is. How noisy do you have to be before their IDS picks up and figures out that you're there? Because you want to give them that information so that they understand exactly how clumsy the attacker has to be before they're going to be detected.
So will the burglar alarm go off the moment you set foot in the house, or are you going to have to stand over their bed and bang on a drum in order to get them to wake up and realize that you're there? That's kind of funny, actually.
Actually, that's a very good analogy, yeah.
And so, continuing this thread a little bit further, what are some of the legal considerations that you have to deal with on a regular basis as a penetration tester?
Yeah, so you need to have a good get out of jail free card. So the organization has to understand in advance what you're going to do. I think even after having documents signed that have been reviewed by lawyers that say, all right, I am going to break into your organization and I'm going to steal data that you don't want me to steal just to show you that I can. After all of those documents have been signed, you still, in going through these steps, say, okay, I'd like to have a meeting now because now I'm going to do this. You understand I'm going to do that, right? Yes. All right, and these are the people that I'm sending this email to, and when they click on it, I'm going to have control of their box, because there's ultimately all kinds of things that can go wrong, in a penetration test, and you have to spend a lot of time thinking about controlling the situation. Mm-hmm. If I send a link to 20 employees, what if they read that webmail or that email on their home computer through their webmail account and click on the link there? Mm-hmm. The employee didn't give me permission to implant my Python backdoor on their home computer, so that could be a problem. What if an employee sees the malware or sees the link and then forwards it off to their husband or their wife, who provides them technical support that says, hey, do you think this is malicious? And then someone from another company clicks on that link. All of those are possible ways that you could get yourself into trouble. I have a couple of stories that are near misses with the customer not quite understanding exactly what it was that we were doing, even though you explained it twice and had it in writing where they said, yes, we understand what you're doing. So communications is important with that, and having good legal counsel is also important for penetration testers.
I'll bet. I can only imagine that there are instances where, also, especially if you're dealing with larger clients, where the left hand isn't talking to the right, and someone hires you for a penetration test and you do that test, and then someone from some other segment of the company gets all up in arms because, as far as they're concerned, someone let the fox into the henhouse. I can see that getting very hairy very quickly.
Oh yeah, and oftentimes it can be an embarrassment to, say, a division or something like that within the company that, wait a minute, someone broke into our systems, or the corporate data was compromised because we didn't patch our systems, and their defensive, the reaction to that is, well, who let this person do this, as opposed to, something more constructive.
Right. So there have been recently a number of attacks based on hijacking the TCP/IP stack. I know that there are certain things that you can and can't talk about, but feel free to speak in general terms, although obviously the more specific you can get, the more interesting it'll be for our listeners. Is Python being used for any of those exploits or tools to defend against them?
So I can talk about how Python could be used to defend against something like that. And this comes back to Python's ability to do data analytics and some of the third-party modules that are out there. You take something like, let's say that I wanted to detect repeated sequence numbers coming into my organization. The reason you might do that is if organizations or an attacker was anywhere where he could intercept communications that you have. So a man in the middle attack, as we call it, where the attacker is between the source and the destination IP addresses and can see the traffic that is flowing back and forth between them. If I can see the traffic that's flowing back and forth between a client and a server, then I can see all of the sequence information and other information that is included inside of the TCP headers that is used for session tracking, if you will, of that connection. And if I can see that information, then I can also see those sequence numbers, or the session information, if you will, and I can retransmit packets that have the same sequence numbers. And if my packets get there first, well, you're going to accept my packet. The first one, well, it depends upon the operating system.
Right.
Maybe you'll accept the first one. Maybe you'll accept the last one. But, you know what? I can transmit multiple times, and I can make sure that I am both first and last. So that would be a typical man-in-the-middle scenario. So if you were trying to just detect duplicate sequence numbers coming into your host, that could be done in as simple as 5 lines of Python code, where just from scapy import asterisk and import the scapy module into your system, and then start sniffing packets and recording. Scapy has a great capability of pulling together all the packets and putting them into a list of associated packets, which, if you're familiar with Wireshark, in Wireshark you can select a single packet. You can say right-click, follow, stream, and it'll pull together all the packets that are part of that same packet. You have similar capabilities inside of Python, or inside of Scapy. So you could pull together all the packets that are inside of a stream with Scapy, and then step through them and just, hey, do I have duplicate sequence numbers? Would be a very quick and easy check for things like that. So, but while you're in there, and while you've got Scapy pulling those statistics, you can pull together all kinds of information, from the time that a specific source communicates with a specific destination, and do you have hosts that establish a TCP communication and then just keep that channel up for long periods of time. Most of our TCP communications that occur on a network are pretty short. I establish a 3-way handshake. I'll download some web page and maybe a couple of GET requests if I'm using HTTP 1.1, and then we'll tear down the handshake. So my communications might be up for a couple of seconds. It's more interesting when you start looking at communications that are up for long periods of time. When do you have communications that establish a connection and then perhaps just send out keep alives for once an hour or once a day and keep connections up for much longer period of times. So analyzing data and things like that with Scapy and Python is useful bits of data that lots of your traditional intrusion detection systems aren't necessarily going to look at. You look at some tools that are out there that'll do things like that, like Bro and others that are useful to you. But yeah, augmenting those types of tools with Python is a good approach for intrusion detection.
Did you say bro, as in, hey bro, don't tase me bro kind of thing?
Yep, don't tase me bro.
Okay.
Yeah, I believe there
is an analytics module like that for it's an intrusion detection system that does analytics, and it looks for anomalies like that in your traffic as opposed to being signature based. It's built into the Security Onion, which is a Linux distribution that has got Snort and other intrusion detection based tools that are all built in, very easy to install. So if you've never played with Security Onion, it's a great distribution for setting up and looking for attacks on your network and getting it up and running very quickly. Running systems that would normally take you weeks of configuration. Doug Burks, who created that distribution, has automated that entire process and made it very simple.
Yeah, I believe there was a Floss Weekly episode where they talked to some of the gentlemen behind the Bro tool. So we'll put the link to that in the show notes. So what are some activities that you do on a regular basis for which you would turn to another language or tool chain rather than using Python?
I would say the other language that I will use is PowerShell, just because PowerShell is the Python of Windows, right? It's built in to every Windows system. I got the interpreter sitting right there, or interpreter, if you will. I've got all the commandlets right there, and it's incredibly powerful. So PowerShell is, I think, is emerging as perhaps the development platform of choice for offensive tools in the environment. PowerShell scripts are going to allow you to put all kinds of things in memory that antivirus software isn't looking for. The PowerShell interpreter is almost always going to be whitelisted and allowed in every environment, and antivirus software looking at PowerShell scripts and determining their maliciousness is I think a while away. So PowerShell is another platform that I'll go to. If I wanted to do any type of password cracking, Python's great for password guessing. So anything where I have to interact with a host on the network and send information back and forth, hey, Python, multi-threading, it's awesome. But password cracking, where speed is critical, obviously a compiled language like C or assembly language is going to be just a magnitude faster than Python, doing very fast encryption cycles and things like that. So I'll turn to C if I have to do something like that. But pretty much Python is the go-to language. I will step out of my Python world and go to PowerShell when necessary, and sometimes C.
It's actually been very impressive to me. I mean, I'm sure since you've been doing this for a while, it sounds like you've been around from the days when pretty much the only way to automate Windows was to go to an outside language, a non-built-in language like Python, or to be stuck writing, .bat scripts and things like that, cmd.exe programs, which are pretty horrendous. It really is impressive how much of, again, that sort of richness of introspection and configuration that is available these days in Windows, they made really, really trivial accessible from PowerShell. It's one of the coolest things to happen in the Windows platform as far as I'm concerned in the last 10 years. So I can only imagine that, it's made your job easier as far as accessing administrative interfaces and the like.
Yeah, for sure. And as more and more environments turn on the WinRM capability, so the ability to do Windows PowerShell scripting remotely to query lots of targets. One, from an incident response standpoint, being able to, from one centralized console, pull back the list of all the processes that are running on every target and a list of all the DLLs that are loaded inside of all those processes, and being able to compare them one to another, just a few lines of PowerShell, incredibly powerful. From the attacker's standpoint, just the ability to evade antivirus, and the fact that is so trivial right now in PowerShell is incredibly useful. But as a Python coder, PowerShell is also really nice because we use square brackets into our lists, and hash tables or dictionaries are very similar in syntactically as they are in PowerShell. So once you get used to all the pipe stuff that you have in PowerShell, it becomes not a very difficult transition for Python coders.
I bet. And definitely object pipelines are really, you mentioned all those pipe. It's a pretty powerful paradigm. It's definitely something, as I say, I'm a Unix guy. I don't use Windows much on a daily basis at all, but I really have to look at that and say, Jeffrey Snover and the other folks in the PowerShell team, that's some pretty deep thought that they did making this product. It's pretty cool, and I actually think the Unix community, not to say that we should all be running PowerShell, that just doesn't make any sense, but that kind of object pipelining capability, I think that's a direction that maybe the other operating system platforms should consider moving in the future.
Yeah, as a Linux guy, I would always turn up my nose to the Windows guys and say, look, you've got one executable with a bazillion different command line options that you can use to do these things. I have one tool that does one thing, and I can pipe the output of that into another thing and cut, and then I can take the output of cut and I can pipe that into, and it was the command chaining in Unix and all of these individual tools that really made it so automatable and scriptable. And then you look at PowerShell, and they've done that, and they've taken tab completion. You can tab complete the options on PowerShell commandlets, and then after you selected your options, if it's something like process name, then you hit tab again, and it actually tabs through a list of all the processes that are running, things like that. So they've taken tab completion to the next level, and as much as you'd like to not like PowerShell as a Linux guy, when you open up that PowerShell prompt and you accidentally type ls and it actually gives you the directory listing, you're like, whoa, what just happened? Even they've got the directory listing looks like your Linux security groups with the everyone group or the owner and everyone else and other and all those other things. So it looks like the security or the directory listing we would see on Linux.
Absolutely. So for anyone who's interested in getting involved in the security industry and penetration testing in particular, what resources or tools would you recommend?
So particularly from your listeners, I'll say that developers make the best information security professionals. There's a big rush of people coming into the information security industry now because there's lots of jobs and there's lots of opportunities. But by far, the people that have a coding background just far excel beyond their peers in this industry. If you can code, if you can write tools, if you can automate processes, you're going to do very well in information security. And just you understand the language of how our computers think. Once you think like a computer, then you're going to be able to, predict how they might make missteps and how you might be able to exploit that or take advantage of that. When I started out as a developer, and then I started doing systems administration and things like that. And I always think of my career evolution has been, after development, I started looking at how to implement or engineer information systems in the way that the people who built or designed the system intended it to be put together. So I'm going to implement a Microsoft Active Directory. Well, I'm going to have Microsoft says I have to have this. Microsoft says I have to have this. And just how do I make all these components work together? So my step one was learn how to build systems and implement them the way that they were designed. And then as I became more senior in the IT field, it was, let me see how I can implement security systems that go beyond and make the systems do things that the people who design them never really intended for them to do. So make it do really awesome new stuff that's beyond its original design. And then finally, when you start doing information security, it's, well, let me implement and make these systems do things that are counter to the way that they were originally designed. So let me make them do things that they were specifically intended not to do. And it's really just the next challenge. I think it's the next logical challenge on how to really find interesting and challenging work in information security. And so I think being a developer, understanding how to start implementing systems, how to take those systems and go beyond what they were intended to do, and then how to make them do things that they were specifically intended not to do, is just the next logical step. There's lots of places for you to learn manipulating systems and exploiting misconfigurations and design flaws in systems. You got lots of security conferences that go on all over the nation, from B-Sides security conferences. If you Google B-Sides, you'll probably find that there's a security conference there, and you're not too far from wherever you live in the United States. There's lots of online capture the flags. If you go to Google and you type online CTF challenge hacking, let's not go there with the word hacking and all the baggage that includes. Just Google it. You'll come up with lots of interesting challenges that'll help you to use critical thinking and come up with interesting ways that you can use code to solve problems. Lots of those capture the flags out there have programming challenges. Like, I was just talking to a guy today. He was just doing a capture the flag, and he used Python to code it. The challenge was this. So you went to a website, and there was an audio CAPTCHA that was on there. So, you go to websites and you click the little play button and it speaks to you. Well, this particular audio CAPTCHA would speak numbers. And so it would give you a PIN that you had to type into the web page in order to proceed past the web page. The problem was that the audio CAPTCHA was always about 30 seconds long worth of pins, numbers that you had to type in. And the web page only gave you 5 minutes or 5 seconds in order to enter the PIN. So you got to listen to a 30-second message and type it in less than 5 seconds. So the solution was Python. So you download the audio capture or the audio CAPTCHA, and you just read it in as a binary file, and then you identify the patterns of the ones and zeros inside the MP3. That, all right, whenever I see this pattern, that is the audio file saying 1, and whenever I see this pattern, that is the audio file saying 2. So you access the web page, you download the audio file, you figure out what the PIN is in there, and then you enter the PIN in less than 5 seconds. So there's programming challenges like that just require you to think outside the box and write code to do it. And they're just great programming challenges, if nothing else, and they're fun. So by learning, doing some of those challenges, get involved in the information security industry. There's lots of opportunities for meetups, and most of the information security professionals that are out there are eager to meet new people and talk shop and teach people who want to come into the industry. Of course, if I can give a plug for my own course, I do teach a class for SANS. I wrote a course called Python for Penetration Testers, SEC 573, where if you're a Python coder and you just want to learn how to start building tools and applying it to information security, you can come there. We'll build backdoors. We'll build SQL injection tools and password guessers and some network reconnaissance tools and things like that as well.
Now, is that an in-person course that you actually have to travel somewhere to take, or is that like an online thing? Or
it is an in-person course. It's offered as a 5-day class. We teach it at various places around the country. You can go to sans.org if you want to find a class and where it's being offered. But there is no online opportunity for that. one of the reasons for that is I think that if you want to learn Python, or if you just want to learn hacking, there's lots of free resources that are out there for that you can go online. You can find online resources to do that. So one of the things that I try to do in this course to differentiate is to add that the instructor-led content, the opportunity to ask questions, to work together on challenges. And there's some interesting capture the flags and things like that go on throughout the class with challenges similar to the audio challenge that I mentioned, and other things that we have to solve together in class as we start from scratch and start building these tools up together.
That sounds great. That sounds really neat. It's one of the things I can absolutely see where the in-person element could really help, because I've sort of been becoming more interested in security of late myself, and I've been trying to go from I build infrastructure by day, doing lots of infrastructure as code stuff in Chef and other things, and I came to realize, I should be more clueful about building these systems in a secure way. So I've been trying to educate myself a little bit, and it's interesting because the amount of there's a lot of information out there, but it seems very targeted and focused, and a lot of it seems to be very sort of aimed at kind of one demographic and one particular niche. So it sounds like this could be a really interesting opportunity to sort of generalize those skills and actually also apply it to some real world challenges as well. That's great.
Yeah, well, let me clarify to say that my course is not how to develop secure code. There's certainly some things that we should think about as coders with, Python is a type-safe language, right? So we don't really have to worry about us creating memory corruption vulnerabilities like buffer overflows and things like that in our code. We can certainly make logical errors and introduce things to our code that make us vulnerable just by unsafe practices, and don't use input, use raw input.
Right.
But underneath, Python still relies on C in many cases, and just last year, March 2014, we had a buffer overflow in the socket module. When you called receive from _ into, there was a buffer overflow in that. So we're not immune to attack, and there's certainly some things that we should do as coders to make sure that our code is secure. Analyze input, make sure that it's of a proper length and things like that. But that's not the focus of my class. The focus of my class is how we can use Python in an offensive capability to test the security of our code. So we're looking to attack other things with Python, not to attack Python.
Right. So obviously your course sounds like a really incredible opportunity, and so for those people who are able to come take it, that sounds like the best approach. But for those people who, for whatever reason, their bosses aren't willing to pay, or they can't travel, or whatever other restrictions there may be, are there any other books or online resources that you like to recommend to people that are in that same vein?
So a good friend of mine, TJ O'Connor, he wrote a book called Violent Python. Mm-hmm. Violent Python it's a cookbook of all kinds of things you can do with Python, from writing password guessers to tools that evade antivirus software to forensics capabilities. So analyzing memory captures and things like that with Python. It's a great resource. There's all kinds of free online capture the flags that are out there from an information security standpoint. Assuming you already know Python. I'm assuming all your listeners already know how to code in Python. But of course, there's Google's Python class, and there's all kinds of universities that have free online Python classes and things that are out there. But once you know Python, there's great capture the flags. Like there's counterhack challenges. Counterhack Challenge is a website you can go out there, and they're going to have all kinds of security challenges. There's Pico CTF, PICO CTF, which is another capture the flag that has security-related challenges, many of which require that you write some code in order to solve them. And like I said, just Googling online CTF or hacking CTF will take you to lots of those particular websites.
Well, that's great. So, is there anything that we didn't ask you that you think we should have, like something that you think our listeners might find particularly interesting that you might have to share?
No, let me ask you guys: 2.7 or 3?
3,
Both.
whenever possible.
Yeah, absolutely. I think that's exactly it. For anything greenfield, it's 3. For existing code bases or where 3 modules are not available in 3, then 279.
279, and make sure to make heavy use of from future import whatever you need.
Yeah. Okay. All right. I would say I agree with you in theory. I'd say many of my Python modules that I use, particularly in the information security industry, were still on 2.7. And I rely heavily on lots of 2.7, so I end up spending a lot more time in 2.7 than I should.
And that's where the when possible caveat comes into play.
Yeah, but I agree with you in principle.
So are most of those Win32 based modules, or are they just general modules that haven't been ported yet?
I would say it's more the latter, more modules that haven't been ported yet. Very large code bases that are out there that do lots of great things, and it just takes a lot of time. And until there is a very compelling reason that says, all right, no, really it's going away, that you've got developers that are just not going to want to migrate their code sets.
Right. I think we're getting there though. Like I think both Red Hat and Debian, or maybe it was just Debian and Ubuntu, pardon me, have said that they're going to be shipping Python 3 as their default Python in their new releases that are coming down the pike. And in at least one case, I know they basically have said, we're not going to ship 2.7 by default at all. You have to explicitly install it if you want it. So I think that while the needle is still definitely pointing in 2.7 land largely now, I think that we're on the cusp of that changing. And the pressure to actually move is building, and I think you're going to see the number of modules where that's the case dwindling over time.
And we've got a 5-year deadline.
Yeah. I hope you're right. I hope you're right. I think you're right.
I think so too, because it's not like this is like a Perl 6 thing. You know what I mean? Like it's not like they said, "Hey, we're going to turn reality on its ear and completely reinvent the language and get into all kinds of really wacky gymnastics." There are some big changes, but none of them are like mind-bending, earth-shattering, this is nothing like everything is wrong kind of changes. They're all sort of like these, I can deal with that when push comes to shove, most of them anyway.
Yep, I agree.
So that's great. So at this point in time, this is where we do what we call picks. Tobias, why don't you start us off?
Sure. So my first pick tonight, in the vein of security, is going to be Authy, which is a two-factor authentication application that is available for iOS, Android, and a few other places. It's got a Chrome plugin. And I've been using that and steadily moving a lot more of the online services that I use to using two-factor authentication, largely because of the convenience that it grants, particularly the fact that it has a browser plugin, so it's not always tied to your phone. So while that does decrease the level of absolute security that you get from it, it makes you a lot more likely to use it. So in the general sense, it does increase your security. And my next pick is OpenWRT, which is an open source and freely available firmware for wireless routers and other embedded systems. And it's essentially a stripped down Linux system with its own package system. And I use it for my Wi-Fi routers. I will only buy a Wi-Fi router if I can install OpenWRT on it. And I actually just recently got a new router, the Archer C7 from TP-Link, which is a wireless AC router that actually is supported by OpenWRT. My next pick is a really excellent talk that I watched recently called Schemas for the Real World by Karina C. Zona. And she's presented it in a number of different venues and over the past few years, the most recent of which was at PyCon 2015. And it is a discussion of a lot of the different ways that as we design and build software, we are influencing the ways that people can actually think about themselves in relation to that software, largely in terms of the different input fields we provide. So one example is a gender input, where usually we provide male or female, but there are a number of people who may be put off by that because they may not necessarily identify by those strict binary conceptions. And just really excellent take on how we can think more deeply about what we build and how that affects the people who use it. And in a similar vein, another really excellent talk that I watched was The Soul of Software by Avdi Grimm, where he talks about, again, how our perceptions and thoughts go into the software that we build and how that gets reflected back up into the people who use that, and how we should be a lot more mindful about how we approach building software and the different considerations that we make while building it. And my last pick is one of my favorite authors, China Mieville. He is a sort of sci-fi fantasy author. He defies categorizing into a strict genre because his works are just so incredibly unique, and he has a really excellent command of language, so I highly recommend that you read anything that he writes. Chris, go ahead.
Very cool. I just have to say, that Avdi Grimm talk, I am just a card-carrying Avdi Grimm fan. His work is phenomenal. I've been following it for years. As I mentioned previously, the Ruby Rogues has been on that for quite a while. I actually still subscribe to his Ruby Tapas screencasts just because I've learned so much about software development from them. And just his blog is great. Like basically anything he writes, any code, prose, that he writes, screencasts that he makes, I can't recommend them highly enough. It's all great stuff. Okay, anyway, my picks. First, I'm going to pick a beer because I like really good beer. It's a beer called Munich Dark by Rapscallion. They're actually a kind of a sub-label, I don't quite know what to call it, of Concord Brewing here in Concord, Massachusetts. It's just a really good dark beer. I get the impression that it was kind of like a special batch kind of thing. I saw it at one of the pubs around here. It was just a really tasty, malty, dark ale. I highly recommend it. My next pick is going to be an application called Write. And this is basically the note-taking Swiss Army knife application for Mac and also iOS, mobile devices. I had kind of struggled for the last several years with various note-taking applications and methodologies, and I had never really quite found one that fit. Notational Velocity, it's an open-source note-taking app, is really kind of nice, but it's kind of fallen into, it's no longer maintained very well, and it's kind of flaky. And Write sort of does everything that all these do and more, and it backends to Dropbox. So I even still have access to my notes in Emacs or Vim or whatever other tools I'm in. It's excellent. The interface is great. It gets out of the way. It supports Markdown inline, which is really nice. So I can format my notes that way and add links and the like. It's just great. My next pick, and I apologize, I have more than my usual round of picks, but what can I say? It's been a week for finding things, I guess, is a place. It's the Marginal Way. It's in Agunquit, Maine, which is a beautiful little seacoast town in Maine. If you've never been there and you're in the eastern seaboard, I highly recommend you check it out. And the Marginal Way is, from my perspective anyway, one of the most romantic places on earth. It is a perfect sort of like date spot. It's where I proposed to my wife. It's this path carved into the side of a cliff overlooking the ocean in Agunquit, and it is just gorgeous. I tried to find a really good sort of online site with pictures, and the truth is none of them even come close to actually seeing it in person. It's breathtaking. My next pick is a restaurant also in Agunquit called Frankie and Johnny's. It is one of the sort of, farm to table kind of places, but it's phenomenal. I'm usually a slavering carnivore. Like I generally think of salad as something that my food eats, But these folks make salads that I would run a mile for. It's just a great place. They're in Cape Nettic, Maine, right next door to Ogunquit. And my last pick, a Python pick for a change. I don't always have a Python pick because the truth is I've only been using it for 6 months and I'm still kind of a noob, is a tool called pyenv. For those folks who work in Ruby, it's not unlike rbenv and the like. It lets you build and manage different Python versions for your development, workstation machine, and it also integrates. It has a virtual env plugin that goes with it, so that for instance, when you cd into your project directory, pyenv will actually switch to the appropriate installed version of Python for that project. It's really cool, and I've found it to be indispensable for working on different things with different versions of Python. And if you're on a Mac, it's easily installable with Homebrew, so it's kind of no muss, no fuss. Just drop it in and it works. That's it for me. That's plenty enough. Mark, please go ahead.
Labs Impacket, which is a Python module I find indispensable. It's got the ability to craft packets as well as communicate over SMB, talking to Windows targets and logging in with pass the hash, and it's got some built-in attacks like the SMB relay attack and other really cool attacks. I also love Google's Recall module, which is a memory analysis module. It also comes with a device driver called WinPmem that you can install. And once you've installed WinPmem, you can just from Python directly access and read all of the memory that you have in your system from kernel space memory to user space memory, and you can analyze exactly what's being placed into memory. You can determine whether or not your applications are really storing that sensitive data in an encrypted format in memory, or whether or not they just say they are. Let's see. So picks. How about this? How about Adam's peanut butter cup fudge ripple cheesecake from the Cheesecake Factory that cost me 5 pounds around my waist last week while I was traveling and staying at a hotel right next to the Cheesecake Factory. I hate you. Let's see. B-Sides Security Conference. The Augusta, Georgia is having a B-Sides Security Conference on September 12th. We've got all kinds of great keynote speakers and normal speakers set up already. It's going to be an awesome event, so if any of your listeners are in the Augusta, Georgia area, check us out at B-Sides 2015 or B-Sides Augusta 2015, and you'll be glad you did.
We just had a B-Sides in Boston, I think, last weekend. I think it was while I was away, in fact, so I didn't get to go, but it seemed pretty cool.
Yeah, it's really, they started out as an alternate conference at DEF CON, and then but it's grown into so much more. You're going to hear the A-side talkers at many of the B-side conferences around the country.
Very cool. So, Mark, how can our listeners keep in touch and follow what you're writing and thinking and producing?
Well, there's always Twitter, at Mark Baggett, one word, MarkBaggett. I blog in various locations, but I usually try to record links to the various blogs that I post to on my corporate webpage, which is indepthdefense.com. You'll see a list of articles and things like that I've posted to there.
Great. Well, we want to thank you very much for taking the time to come and talk to us today. It's been a really interesting discussion, and I'm sure our listeners will come away learning a lot more than they ever thought they would about security. So thank you very much, and we just really appreciate you taking the time.
Yeah, well, thanks for having me. I enjoyed it.